Morning, everybody. Thanks for coming to the Data Colada seminar series. It's my pleasure today to introduce today's speaker, which is Devin Pope, who's going to be talking to us about the law of demand in a large-scale field experiment. We're joined by four panelists today: Christina Exley, Tatiana Homanoff, Kelly Chu, and Richard Thaler. As well, Joe Simmons and Yuri Simon will be here to ask questions and interrupt Devin as he goes. For all of you, you'll see that you can submit questions through the Q&A function. Devin's going to be awfully busy, but the rest of us up here will do our best to try to read those and, when possible, interrupt Devin to ask those questions. But with that, Devin, I hand it over to you. It's your show.
Wonderful. Well, thank you so much, Laith, and thanks for everyone who's joining, especially the audience members or the panelists for being here and helping out. I'm excited to present this paper, so let me share my screen. So the paper I'm going to present is called Unveiling the Law of Demand Using a Large-Scale Natural Field Experiment. It's very recent work. We actually haven't released the paper yet, but it'll be out in a couple of weeks. It's joint with John List, Ian Muir, and Gregory Sun. And looking forward to getting all your thoughts and feedback on this. So to motivate just a little bit, let's imagine that you're in Berkeley, which I assume like all of you have been in Berkeley, and you're at Berkeley Bowl getting some sort of exotic fruit. And then you want to move from there to, say, the Botanical Gardens. Well, you might pull out your Lyft app and try to grab a Lyft for this ride route. So if you're going from Berkeley Bowl to Botanical Gardens, you might get something that kind of looks like this. So the standard Lyft ride is here, and it's when I looked this up, it was being listed at $9.93 to take that ride. There's also a wait and save ride. This is actually a new thing that it's happening just because of COVID. Normally this would be a shared ride where it's a bit cheaper and you would get in the car potentially with somebody else. But now you have a decision to make of whether or not you want to take the ride or not. Economics has a little bit to say about how you would interpret and think about these prices. And in particular, there's something called the law of demand, which suggests that that quantity demanded goes down as prices go up. And that's been a pretty good law. It's about as close to a law in the social sciences as you can get. And so you have a decision to make. Now, let me show you just a sneak peek of the data to kind of give a sense for what I'll probably be talking about today. If you take data from Lyft, for a 7-month period in 2019, there were 1.7 million standard rides that were offered with a fare between $10.96 and $11.03. All right, so we have a bunch of rides being offered in that little window. Let me show you the conversion rate, or the number of people who ended up taking a ride on Lyft within 30 minutes of being presented with that standard ride fare. All right. So for the prices between $10.96 and $10.99, you see that people were converting at a rate of right around 50% or just above 50%. For $11 to $11.03, the conversion rates were around 48.6 or 7 or 8%. Now, if you ran a regression with these data points, you would indeed find that the law of demand holds, right? As prices go up, demand goes down, quantity demanded goes down. And so you would see that there's a downward sloping demand curve. But obviously from what I'm showing you, I'm suggesting that there's something a little bit more under the curtains going on in terms of how people respond to prices. Okay, so I've already kind of motivated. The law of demand is an important thing, and estimating elasticities is an important part of getting predictions and optimizing if you're a firm. And so today we're going to think about, well, what is the behavioral contribution to the law of demand? Do demand curves really slope down and do so in a smooth and continuous fashion? Or is the downward slope of the demand curve concentrated at a few select points along the demand curve? All right. And this is going to be built on an underlying psychological bias called left digit bias. You've probably heard of this bias, and even if you haven't, you can probably guess what it is by looking at the name. But left digit bias, right, is the idea that we focus on leftmost digits when we look at two numbers. So these first two numbers look very similar to most people. These second two numbers feel kind of different, even though they're actually closer together than the first two numbers. And it's kind of natural. It's not crazy that people focus on leftmost digits. They're usually the most informative digit in a number. But this leads to what has been referred to as 99-cent pricing, where there might be some value to pricing at just under a dollar value, so that left digit is smaller, and we see lots of stores and different places doing this type of pricing. So I want to, given the format, I'm not going to actually spend very much time talking about related literature, but there is a lot of other work, including some that I've done on with co-authors, that explores left digit bias in various domains. There's also been really good work in marketing, psychology, and management, so other fields other than economics that have especially looked at the underlying mechanism of what's going on, which I won't have a lot to speak about today. Needless to say, I think the paper that we're presenting today adds to this literature and is complementary. And I think it's going to provide some value that I'll try to point out a little bit as we go through the talk relative to the current literature. All right, we doing all right? All right. So the setting here is going to be Lyft. So everyone should know about what Lyft is, I assume, but it's a rideshare app, right? It competes with Uber in the space. They provide two main products that I'm going to talk about today. There's the standard ride, which is where a single passenger is matched with a single driver. And that's the majority of rides that Lyft fulfills. There's also these shared rides where multiple passengers can get in. So this is like a carpool type option. These rides are cheaper and yet can come at a bit of a cost to the passenger. How does Lyft set prices for these rides? I won't be able to tell you exactly. There's a complicated set of algorithms, pricing algorithms that they use that are based on a lot of factors, including things like just the distance and duration of the trip, but also availability of the drivers. And their goals are, of course, to maximize short-run profits, but they also, are introducing different products. And so they have kind of different strategic interests in mind as well, sometimes when they're pricing. But yeah, I'm going to show you a little bit of evidence of what their prices look like, but their pricing is in some ways very strategic and well thought out. So for example, Lyft randomizes 10% of all of their rides. They're randomizing their prices on those rides in order to compute very precise price elasticities and update their pricing algorithms using the price elasticities generated by those rides. So this already shows a level of sophistication that they're using, and we're going to also come back and use this random variation when thinking about our effects.
So Devin,
yes.
When you say they randomize, it must be within some limits, right? You
That's
can't
right.
get $1 million fare.
That's right. Yeah, and the limits kind of depend a bit. I don't even know exactly what the limits are, but yeah, think about going up or down by maybe 10% or so in any given ride.
Great. And I was also thinking about the setting. It seems like the underlying complexity could be an important feature here. So one thing that's nice about $11 relative to $10.99 is 11's easier to think about. But so I was wondering, are they showing final prices, or is 11 actually not maybe easier to think about because taxes are going to be added afterwards anyways?
Yes, so these are final prices. So it's the actual price you pay. And you're right that there's something kind of special about a very round number. Now, you could think about the $11.01 bucket compared to the $10.99 bucket if you want to get around kind of the round number stuff. But I actually will show you that there seems to be a little bit something special about the exact round number. So that's a good thought to allude to for here in a minute. Good. All right. So I'm going to show you a few results today. I'm going to show you some observational data, mostly just a bunch of graphs that kind of show how this effect plays out. But I'll do just a little tiny bit also of talking about kind of how, if you wanted to structurally estimate a parameter or something, but don't freak out or log off yet. I'm not going to do very much of that. And then I'll show you some results from a field experiment as well that Lyft ran. And then we'll end by kind of having a broader discussion about just what's the overall impact on both Lyft, but also on their riders from employing these types of pricing strategies. So the observational data is going to come from about 600 million different ride offers that were made to Lyft riders. So these are called sessions. So when you open your app, you enter in a destination and they offer you a ride at a particular fare, that's considered a session. And I'm going to show you data from two different marketplaces. There are some marketplaces that only have the standard ride option. And then there are other marketplaces that have both the standard and shared ride options. All right, so in a big city like the Bay Area, in a big kind of metropolitan area, you're going to have both options, but in a lot of smaller places, you're going to only have a standard ride option. You can see that about half the data is coming from, the data are about split between these two types of locations. The average price is around $16. In the places where a shared price is offered, the prices are about 25% less than the standard price. Conversion rates are around maybe 50%. And when both standard and shared rides are being offered, standard rail rides still take up the market share. It's the primary option chosen by most consumers in this space. And we'll have a few other variables that we might talk about briefly at some point. All right, so let me show some data. So don't focus too much on this graph because this one's really ugly, but I wanted to show the full price distribution. So this is, if you want to see the entire price distribution of all rides that were offered by Lyft over this 6-month period or 7-month period, this is what it looks like. And it's kind of a mess, especially here at this lower range. And that's for a variety of reasons. There are like minimum fares, and if you're going from airports, there are certain fees. So you get a lot of like bunching and weird stuff going on. But let me show you now a prettier graph that is focused on kind of the meat of the distribution between about $10 and $30. And that's what this looks like. So I've just gotten rid of kind of the messy bottom end of the pricing distribution. And I've also gotten rid of the low volume, high end of the pricing distribution. And so let me be precise. I'm going to show a bunch of graphs that look kind of like this. So let me make sure everyone understands what I'm showing here. So each dot is a 10-cent bin. So the dot that's, for example, right on this $15 line, those are rides that had fares between $15 and $15.09 for the standard price that was being offered, right? And then the next dot are fares that were offered between $15.10 and $15.19. So I'm just doing them in 10-cent bins. And you can see that there were about 1.5 million rides that were offered in say each one of these 10-cent bins, depending on kind of where you're at in the distribution. All right, and importantly, the point of this graph is to show that Lyft during this time period was not doing any sort of 99-cent pricing strategy, right? They were just as likely to offer a $19.99 ride. I'm sorry, they were just as likely to offer a $20.02 ride as they were a $19.99 or $19.98 ride, right? So you see that it's smooth. And let me show you also the shared prices. This distribution has a little bit more kind of weirdness in it for various reasons. But again, you don't see that they're doing any kind of consistent 99-cent pricing strategy where they're doing a lot of fares that are just below dollar values. All right. Does this sound good to everyone? All right. So now for...
Sorry, quick question.
Please go ahead.
You probably get to this soon, but I just want you to think about it. You talk about conversion. So what happens if I check, don't get it, but then in 2 minutes I do it again? How do you, like, what does it mean to convert? At what point I'm a new person versus not?
Yeah, good question. So this is starting to get into some of the institutional details that I'm like the worst co-author on this for. My 3 co-authors all work at Lyft, at least in part. So a session is a 30-minute period. So my understanding is if you log into the app and then you log out and log back in, they keep that, they kind of store that price, and so you get the same price for 30 minutes. And so what we're looking at is a conversion rate is, did you end up taking the price that was offered to you sometime in the next 30 minutes? If you log into the app, say an hour later, you can see different prices, and that would be a new session where you could then convert or not convert on that session.
Devin, another question.
Yes.
You had talked about interpreting this in terms of left digit bias. I wonder if there could be something else going on as well, which is consumers are used to seeing round number prices or 99-cent prices. So when they see other numbers that aren't round or don't end in 99, they might have the sense that, oh, the algorithm is being used against me, Lyft is doing fancy strategy, I'm a victim of surge pricing. So then they just dislike these prices that they're not used to seeing because they suspect that they're being the victim of something.
Yeah, very cool question. Yeah, I think that's a really interesting thought. I mean, I think it would make certain predictions. So for example, it sounds like what you're saying is you kind of have a model in your mind where if we offer something at exactly the 99-cent mark, they're going to be really likely to take that because it feels maybe normal to them. Whereas if we offer, say, the 98-cent mark, they're not going to take that because that feels like we're tricking, they're getting tricked or something. And so I'll show you here in a second the exact kind of response to each cent mark.
Mm-hmm.
And you'll see that it doesn't appear that there's anything like super special happening at 99 cents or even the round dollar mark all that much.
Okay.
And yet you'll see what appears to match a model of left digit bias instead. Yeah, good question. All right, so let me show you what is perhaps the primary figure of the paper. So here is, on the horizontal axis, we have the standard price that was offered, again, in 10-cent buckets. On the vertical axis, we're providing the probability that you converted, right? Or this is actually the non-conversion rate. So this is a metric that Lyft cares a lot about, right? So did you not end up taking the ride once you saw the price? You can see that when people are offered really expensive rides, they're less likely to convert than really cheap rides. I mean, these are different types of rides. But people the conversion rates are lower for expensive rides versus inexpensive rides. But the really thing that kind of sticks out in this figure, at least to me, and especially the way we've drawn on and everything, I understand, is that there are these pretty massive discontinuities that are occurring in the non-conversion rate at each dollar amount. So in the data sneak peek, I showed you this $11 mark. I showed you the 8 cents just around the $11 mark. This graph shows that I wasn't cherry picking the data that much. I could have done the same thing at the $12 mark or the 13 or the 14 or the 15, kind of all the way up to 30. You see this very consistent pattern where you're more likely to take the ride if you're just under the dollar value than just over. This is looking at all conversion, but we can also look at what did you convert into. So this next graph I'm going to show you is again showing the standard price on the horizontal axis, but now on the vertical axis I'm going to show you the probability that you converted to the standard ride. So now I'm going to be restricting the data to markets that had both the standard and the shared option. And here's the probability that you convert to the standard ride. You can see that the data are even a little bit more stark here, where if you move from, say, $13.99 or $13.90s to $14, you're significantly less likely, I haven't said anything about significance yet. It looks like you're way less likely to convert to the standard ride as soon as you cross over that threshold. Now you're probably already thinking, and my guess is this is 100%, you're thinking, well, what happens to the shared rides as the standard price crosses over that threshold? So is there some sort of substitution effect? And that's this graph. So now I'm still plotting the standard price on the horizontal axis, but this is now the probability that you take the shared ride option. So as you go from, say, $14.99 to $15, the probability that you take the shared ride actually goes up. So what you're seeing is as you cross over that threshold, for the standard price, you're more likely to take the shared ride, you're way less likely to take the standard ride, and overall, you're less likely to take any rides. But there is a bit of a substitution effect where you're more likely to take the shared ride as you cross over. Now you can look at these exact same graphs, but replace on the horizontal axis the standard price with the shared price, right? And see what happens as the shared price starts to hop above and below these round number thresholds. Does that make sense? So here is the shared price on the probability of not converting. It's not as stark, which is what you would kind of expect if people don't care about the shared price as much. Since fewer people are kind of opting into this ride, but you still see that there are these discontinuous jumps that occur as you cross over this shared price value. You can look at the impact of shared price on shared conversion. And so as you cross over a threshold, you're significantly less likely to take a shared ride when the shared price just becomes over the dollar value. And then again, you can look at the substitution effect. So this is the probability you take a standard ride based on the shared price. And again, you see this substitution, whereas as the shared price goes from $14.99 to $15.99, you're more likely to now take the standard ride because now the shared price feels relatively expensive to you, or whatever the mechanism is that we can kind of come back to in a bit.
Devin, just a clarifying question.
Yes.
Does the standard price and the shared price, do they move around independently? Are they independently randomized, or is the shared price always a fixed percentage of the standard price?
Great question. Darn, I don't know exactly. I don't think it's just a fixed percentage. I think different markets have different price elasticities for shared and standard. It could be within some smaller market there's like a fixed percentage, but this is actually something I don't know. I would be, there's zero chance that there's a fixed percentage across the entire US in terms of the prices. And we could obviously just look in the data to show that. Yeah, so I'll have to look into that more. Thank you, good question. Devin?
So do you have a sense within the shared price why it was upward sloping in that conversion rate in some of the graphs? Right.
In something like this?
Upward sloping within a bin?
Within a bin, why is it upward sloping? Yeah, so our explanation so these are different rides, right, that are being offered. And so let's imagine that you only pay attention to the dollar digit. You don't pay attention to cents. Then for a given ride, you kind of have a sense for the distance. It feels like a better deal. The rides that are being offered to you at like $19.99 versus $19.01, you're like, wow, that's a pretty long distance, and I'm being offered at 19 something. And so you could see if they're not paying attention at all, it just feels like a better deal within the dollar bins. Now, if we restricted to the same ride and then move that, then it would be downward sloping within this bin. But because these are different rides, you can't think of this as like a demand curve. These are different products. Yeah, good question. Yuri, did you have a comment as well?
I was going to make a similar comment on the very first graph that you showed, that I think of these all as like little inchworms. And these are pretty flat little inchworms, which is, almost highlighting your point even more, that the only thing that I care about is dollar jumps. That it seems like these conversion rates are completely flat within a dollar bin, which is all the more striking.
Yeah, thanks for putting that out, Tatiana. That's what this kind of structural estimation is going to do, is it's going to determine exactly how much of the slope in demand is being driven. But as you're alluding to with just the kind of reduced form figures, it's clear that these discontinuities are going to be a pretty major impact on how and why these curves are sloping the way they are. Yeah, thanks.
Yeah, my question was actually from an audience member. So was pointing out that there's no discontinuities, Chris Carndall, between, let's say, 19 and 20, or the discontinuity is not larger when you cross the dollar amount, suggesting it's more people ignoring cents and people paying more attention to the left digit. You probably
So great comment. So we can estimate these discontinuities, or even more. We can estimate our structural parameter that I'll mention here in just a minute for each dollar value, and it ends up that for most the especially round numbers like $20 and $30, you can see that usually the discontinuity is actually a little bit bigger than some of the other dollar values, but not much. So this isn't so much a left digit bias per se as it is we just ignore cent values and only pay attention to dollar values. This is kind of actually one of maybe a weakness of a left digit bias model is because it changes a little bit depending on the context you're in. So an earlier paper that I wrote with co-authors, we were looking at car odometer values. And there you find that they're in like 10,000s. And so we were finding at the 10,000 marks, there was really interesting stuff happening. Whereas here, it's kind of very much you're focused on the dollar amount and nothing more. But yeah, it's a great point that we're seeing just barely larger effects at these especially round numbers. All right, so let me go back to something that I think will help answer, Kelly, one of your earlier questions, is let me now show you, so all of these dots are at the 10-cent bins, just to make the graphs a little bit easier to read and everything. But you might want to know, well, what's happening right around these discontinuities? Is this occurring right at the 99-cent mark as you cross over the dollar threshold? Or is it just getting kind of really steep in that range? And this is actually relevant. So a lot of retail companies, for example, will price items not at the 99-cent mark, but at the 95-cent mark. Or for example, Walmart does the 97-cent mark. And one of the reasons why when you talk to some of these execs, they'll say they're doing that is because they are worried if they price at the 99-cent mark that people will round up in their heads. And so once you get to 99, they just round up. But so what you really want to price at is like 97. Right? But we can look at this very directly in the data to see if there appears to be a point at which people start to kind of round up in their heads. And so I'm going to show you each price, but I'm going to stack the data for a bit more power. And so here, I'll just show you the graph. So this is the conversion rate for all prices that were exactly at a dollar value. So this is the conversion rate when you average across 10, 11, 12, 13, $14 prices. These are the ones that were at $9.99, $10.99, $11.99, $12.99, right? And these are the 98 cents. So these are the 15 cents leading up to the dollar value and the 15 cents after. And this is the standard price on non-conversion. And so here's our jump that occurs, right? When you average across all of these discontinuities. And you can see that it really does seem to be happening. The 99-cent one, it doesn't look like you're kind of rounding that up and treating it like the $11 mark. It is being treated like, say, the 98-cent mark. Now, exactly on the $11 is a little bit interesting because a pure left digit bias model would have this dot being kind of more up here, right? Because it's just like an $11.01 thing. So the psychologists on this call could probably do a better job of this. Maybe it's something about number fluency or, I don't know what it is, but there's something, or maybe it could be some sort of signaling like you were talking about, Kelly, where they feel like they're getting a better deal if it's exactly at a dollar value or something. But anyway, but it's not huge. It's still not as good as doing all the way down to $10.99. Here, let me also show you, this is the probability of the standard price on standard conversion. So again, you see that it's really dropping at exactly the left digit, whereas this one's maybe a little bit higher than you would have expected. And you can also look at this, the standard price on shared conversion, and you see kind of a similar thing where when the standard price crosses over this threshold, now you're more likely to take a shared ride. And again, this dot is a little bit of an outlier. Anyway, but there doesn't seem to be a lot of merit between pricing at, say, the 95-cent mark versus the 99-cent mark or something. Oops, sorry, I was pointing the wrong dot on that one. This one looks a little bit more normal, but anyway. Good, all right. Any thoughts or comments there? Does that sound all right? All right, so the next thing I want to mention real quick is the structural thing that I'll go through kind of quickly. So you can put a little bit of structure to think about what is the magnitude of these effects. And so basically we write down a simple model that's been used by people before to think that's usually built on an inattention framework where you pay attention to the dollar amount, but you discount the cent amount by some amount theta. And this theta value can just range from 0 to 1. If it equals 1, then you're not paying attention to the cents at all. So this is kind of what Tatiana was saying, where you're just looking at the dollar amount. If theta equals 0, you're back to just a standard rational kind of neoclassical framework where you pay attention to the cents amount just as much as you pay attention to the dollar digit. And so if you had something in the middle, say theta equals 0.5, the way you would interpret that structural parameter is that the quantity demanded drops at the 1 cent mark by the same amount as the equivalent of about 50 cents worth, right? So it's worth like 50 cents when you are able to hop over that rounded dollar value. So that's what a theta of 0.5 would mean. And so in order to get this parameter value and think about, well, how much relative to a price change, how large are these discontinuities, you have to have the price elasticities. But as I mentioned, this is a fantastic place to do this because we actually have randomization. And so we know the price elasticities at different places along the demand curve because Lyft has been running all of these experiments constantly. And so this, for example, are what the price elasticities are for Lyft at different price ranges. So the own price elasticity for standard price is around 1, and it gets a little bit more elastic as you get into higher price points. And we also have, for example, cross price elasticities. This is the cross price elasticity. When standard price goes up by a little bit, how does that change your shared price quantity demanded? And these are the cross price elasticities at different dollar values. Anyway, take all of that together. And the point is we can say, okay, how large is the discontinuity relative to a price change? And you can estimate this theta parameter, and you can estimate it using own prices for standard or shared, or you can estimate it using cross price elasticities. And no matter how you do it, you get somewhere pretty close to theta equals 0.5. And it's actually, I'm like stunned by how robust it is that you can get the same parameter value, whether no matter what product you're using and whether you're using the substitution effect or the own effect of that product. I think it's actually a pretty fascinating result that it tends to be that robust across product types. And if you're really into econometric theory, in some ways, I'm sorry, if you're really into microeconomics, you might be really excited about this. This tells you something really cool about some sort of like Hessian matrix or something that's symmetric in the way that some of our assumptions would make. Now, you're not excited about the fact that people aren't looking at the cents very much, but you're excited about, conditional on that, you're excited about these results. I can show one more thing about how robust this tends to be. So a lot of biases that we'll study in psychology and behavioral economics, things like loss aversion and present bias and overconfidence, they vary a lot by individual and by context, right? There's tends to be a lot of heterogeneity. Does this theta parameter, or does it vary, this left digit bias parameter, does it vary a lot by individual or context? And the answer is basically no. So here we're estimating theta off of either the standard or the shared response for different types of users, high frequency users and low frequency users, people with business accounts, people that are leaving from an airport. And you can see that, man, it's just super consistent. People seem to treat a change in the crossing a dollar threshold as about 50 cents. No matter what person you are or what context you're taking that ride. And importantly, these people are different. They have different elasticities. So for example, business riders, those that are having a business account, they are more inelastic, right? They don't care about prices nearly as much. Their demand curve is much steeper than non-business travelers. And yet the discontinuity that occurs suggests that they're paying attention to the price in the same way as the non-business user.
Somewhat related to this idea of heterogeneity, there's, I guess, related to one of Kelly's earlier questions of, do the shared versus own rides track together in the same percent? If that's not the case, there's going to be some times where if I have this bias, there's a lot of money left on the table, and other times when there isn't. And that would be a really interesting heterogeneity to look at. Do people overcome these biases when making the switch to the share ride is going to be much more costly than another scenario?
Mm-hmm. Yeah, that's cool. So we could even use some of the random price variations. So let's say you're in one of the buckets and you randomly get like a really bad shared price or something. Now, does that help you overcome the left digit bias on the standard price or something because there's more there? That's interesting. Yeah, I'm not sure if we could pull that off or not, but it seems doable, at least kind of intuitively. Great comment. Thank you. Good. All right. Oh, go ahead.
You don't have identifiers of the users, right? Just the session.
We do have user identifiers.
Oh, and do you do heterogeneity that way as well, or no?
Meaning like plot some sort of distribution of theta values for users where we have enough observations for the user to get a reasonable estimate, maybe?
Right. It's just like some people completely ignore it, and most, I guess, if it's 50%, it wouldn't be that. But it could be, let's say, the axiom would be 50% of people completely ignore it, and 50% do not ignore it at all.
Yeah, and those people don't happen to be more likely to be business travelers, or they don't happen to line up with any of these categories. Yeah, that's really cool. We could do that. So especially for high frequency users where we could get a pretty good theta estimate just within an individual, well, it would require you having a fair number of rides around a discount. Yeah, I don't know how noisy each individual theta parameter is. Might be that we have to aggregate up to some level like this to make that work. But it's something we hadn't considered. That's a great thought. Thank you.
This is a question from one of the audience members that I thought was interesting. The audience member is talking about rumors that I've also heard of. I'm not sure if they're true, that Uber spies on Lyft's pricing and may try to act competitively. So I can imagine a version in which, suppose Uber programs its algorithm to basically have a left digit bias. When it sees that Lyft has moved up $1, that's when Uber swoops in and tries to offer the lower price.
Yeah. So I will not speak to the allegation of price spying. I don't even know if that's illegal or not. But yeah. So here's one thing I can speak to is that Uber is not doing 99-cent pricing either. You can pull up your Uber app and get an $11.01 ride. I would be stunned if after this paper comes out, if that doesn't change soon. But yeah, there's some really interesting, like competitive pricing strategies that one might have to worry about, especially in a kind of a duopoly type situation. Yeah, very cool. All right, let me just very, very quickly say we also ran an experiment after obtaining these observational data results. So at the end, from the end of 2019 to the beginning of 2020, for about a 2-month period, Lyft rolled out an experiment on their platform nationwide that randomized about 21 million passengers into one of 6 experimental groups. So there was a control group where 50% of the sample was put in this control group. And then 10% of the sample was put into each of these treatment groups. The treatment groups would either round standard down the price or not change standard, and then they would do different things with the shared price. So let me explain what it means to round down. So what they would do is they'd run their standard algorithm. If the price ended up being within 10 cents of a dollar value, so say the pricing algorithm produced a price of $11.07, then it would round that down to $10.99 if you were in one of these 3 treatment groups, treatments 2 through 4. The same thing they could do with the shared in the treatment categories where the shared was rounded down. They also rounded shared up occasionally for reasons that I still don't fully understand. This isn't probably the exact, this is for sure not the exact experiment I would run, but it's the experiment that was run. And let me show you. In fact, we can predict based on our observational data what the increase in profit per user would be from each of the 5 experimental categories relative to control. So if you believe our observational estimates, then this is the profit increase that you should expect to see. So you can see that these last 2 treatments, we actually didn't even really predict that profit would go up. And this one was expected to lower profit. So we were, but anyway, I'm not going to go through kind of everything because it can be a little bit tricky to show to show exactly how profit is calculated in different things. But let me show you the end results from the experiment on profit per user for these categories. So by the way, these results aren't incredibly statistically significant. It shows how much statistical power one has to have actually to identify effects of this size. But you can see that these bottom 2 treatments that we didn't really expect to have much effect didn't have much of an effect. These top 3 treatments did have some effect, these 2 being statistically significant at kind of conventional levels, where profit increased by about, somewhere around maybe 0.3% per user. So since this experiment ran, Lyft took this highest performing treatment and rolled it out nationwide. And so this is currently the treatment that's being run. Nothing else has changed. Shortly after this experiment, COVID happened, and there was some obvious reluctance to make a lot of changes to algorithms and different things for a variety of reasons during the last while. And so this has been the final state of experimentation at Lyft on this, even though there will surely be further waves of experimentation. This leads to the natural question of what is the value to Lyft of this experiment? So I'm giving percentage numbers here. This is going to feel a little bit anticlimactic. So just earlier this week, the legal team at Lyft gave us new instructions on what we could and could not disclose. So whereas previously we've been talking about certain numbers, I've now put an X in here. So we're still trying to figure out, anyway, I can't precisely talk about these numbers today, but they're big. So here's one thing, let me say one thing. So
just tell us the left digit, Devin.
I think I can say, think of these as on the order of tens of millions of dollars per year in profit. That's after taking into consideration driver take and things like that. But that's just for the sake of discussion and to think about kind of what this means for thinking about how companies work and various things. Now, we actually estimate that they could make a lot more money not using the experimental treatment that they're currently using, but rather taking a more aggressive pricing strategy. Basically, our model suggests that they should basically set every price at 99-cent mark. This goes back to your point, Tatiana, of the effects are so large that you basically should never price within a dollar range. And so, yeah, so if they did that, then there would be even more profits per year. And I think this raises an interesting discussion kind of question of, well, why is it? There's this kind of new literature in behavioral economics about behavioral firms and stuff. Why is it that such a sophisticated company that's using such sophisticated pricing algorithms, why is it that they didn't detect this or implement this? I mean, it's a pretty, a few lines of code on top of the pricing algorithm can then round or whatever to the 99-cent mark. Why is it that it was taking so long? Or maybe you think this is short, right? I mean, Lyft has only been around for so long, right? But yeah, happy to hear any of the panelists' thoughts on that as well, right? Does this surprise you that Lyft is not taking advantage of this, or is this, oh, this seems perfectly fine?
I guess the question in my mind is, suppose that they did all 99-cent pricing. Does that actually, now we're in a world where that's a setup where people are getting over their left digit bias because all of the prices have 99-cent pricing? And that's sort of like, related to my earlier question of like, I'm super curious to see, is there a scenario where people stop having left digit bias Or is this something that they're always going to exhibit no matter how much money they're leaving on the table?
Yeah. Yeah, it's a great point. There is a question, I think, about some of kind of the general equilibrium effects of all of this. We looked at that some from the experiment. So those that were randomized and started getting more 99-cent prices, you can look at their long run behavior. And if anything, it looks very positive. For example, they're actually more likely to show up again after they've taken the ride. So you might say, yeah, it like tricks them or something into taking the ride, but then they're gonna like leave with a bad taste in their mouth or something. And the answer is it doesn't seem like it's that at all. If anything, the opposite. People have kind of a memory of a really good price. Now, is it possible that if you kind of hit them with 99-cent prices over and over and over again, they start like losing their left digit bias? Maybe, or maybe it gets even stronger. I don't know. There's kind of the very long run effects that we haven't been able to measure. Now, gas stations and stores and things have been doing this for the very long run, and I don't think there are real noticeable negative effects there, and so I wouldn't imagine it here either, but I don't know.
Presumably Walmart still charges 97 cents.
Yes.
So that tells you something. I don't know what, but that they're no dumber than Walmart. And Walmart is a lot richer than us.
Yeah, I think there's a really good question about like how sophisticated are these firms being with kind of psychological effects in addition to kind of some of the standard econ. So I work part-time at Amazon, and I mean they're running experiments all the time, of course, that are related to like nudging and psychological type effects. So it's not like they're not considering these types of things. But there could still be a lot of things that they are leaving on the table, and like hiring psychologists and behavioral economists suggest that they know that. Kelly, did I see you had a comment?
Oh, sorry.
Go ahead, Kelly.
I was wondering if Lyft is also considering doing this in terms of how much it pays the drivers, or is there a similar pattern in which the drivers respond just to the left digit, so we should always round down in terms of how much we pay them?
Oh, interesting. Yeah, so I know of no discussions that have talked about changing the driver's compensation. Well, I mean, technically it's the riders that pay the drivers, but you could change that setup. Yeah, good question. I don't know if it's something that's been considered internally or not, but I haven't been privy to any discussions of that sort.
I don't think the driver turns down the ride very often. So I don't think that there's much room there.
Yeah, it could be that it's kind of truncated. So
Devin.
Oh yeah, please go ahead.
So I was wondering if there's much work either with this paper, maybe with survey evidence or some of the other work you've done. Are people being inattentive in the sense that if you ask them to add up a series of numbers, they would have miscalculations that would be predicted by left digit bias? Or is there any evidence for a different channel that was also suggested by an audience member that maybe I just set thresholds that are perhaps common in like the medical field where, you know, anything less than $12 is what I'm going to do. And it's not that I'm failing to notice the right digits. It's just my thresholds are such that you would get this result.
Yeah, great question. Yeah, really good question. So there has been some mechanism work done on this. My read of that literature is that it appears that inattention is almost surely the leading mechanism for this type of thing. So for example, let me give an example of the type of, there are memory studies that they'll do. So you can show people a price of an item, and then some other things about the item. Maybe you're showing them two items and then they make a choice, and then you move to the next page and you say, oh, by the way, now we have a recall task. Can you remember what the price was of the toaster? And if the price was $9.68, people say, oh, it was $9 and if you force them to respond, oftentimes they'll say it was $9.50. They like choose the midpoint. A lot of people choose just $9. Other people choose $9.99, even if it was $9.68. But anyway, that's, I think, pretty suggestive, at least, if not somewhat conclusive, that to some degree, this is they weren't paying attention or fully internalizing the cent value. Now, there are other models, psychological models like categorization effects, where it's not like you weren't paying attention. It just feels different, right? A $12 thing just feels different. You can say, oh yeah, I know it was $11.97, but that feels cheap and $12 feels expensive. And that could surely drive some of these effects as well. But there's at least, I think, some evidence of inattention going on.
Yeah, I think that's super interesting, and maybe that speaks to some of the equilibrium effects that we would imagine if I fundamentally change the price scheme to always involve 99 cents. Maybe people are going to notice that, and I wonder if that might give us predictions about whether this actually could, in the long run, be a good idea. Versus maybe if it was just, you know, these categorization or threshold types arguments, maybe I can't fully think through if that would actually be bad or good for the equilibrium as well.
Yeah. That's actually a good segue into my very last slide and my last point. And that is maybe this was bad ordering, but I focused a lot on the value to Lyft. What about the value to customers or the effect on customers? So let's think about some of the welfare implications for consumers. And part of the reason why it was ordered that way is we really can't say much about the welfare implications. Let me give you an intuition for why that is. So consider a consumer who's maximizing their utility subject to some budget constraint, right? They're choosing some bundle of goods. You could say, well, when Lyft starts to do 99-cent pricing, and if the consumer is inattentive to prices, well, then they're going to consume more Lyft rides. And that's what we show is Lyft demand goes up. Right? So Lyft rides are more likely to be part of their consumption bundle. And you could say, well, they're over consuming Lyft. Well, the answer is it kind of depends. It could make them worse off if they're over consuming Lyft rides. But let's imagine that lots of the other goods in their consumption bundle are also being priced at 99 cents. So when they go to Walmart and buy bananas, they're seeing 99-cent pricing there. Then if you're not seeing it Lyft, maybe you're actually under consuming Lyft rides. Because all of your other items that you're purchasing, you were over consuming relative to Lyft. And so actually adopting 99-cent pricing puts Lyft consumption more in line with what you would have if there wasn't inattention. Now, this point has been made kind of more formally, and anyway, Basu in 97 argues that that if all firms did 99-cent pricing, then it wouldn't be irrational anymore for consumers to be inattentive at all. Because there's no extra information from the cent value. And it's actually the firms that have a welfare loss relative to a world of no inattention, because then they can't use prices to adjust their demand as closely as they would want. Anyway, so the welfare implications here actually end up being really tricky. It also depends a little bit on the mechanism of how people are thinking about it. If $11.97 just feels bad to people and they don't like that, well, if you want to include that as part of the welfare calculation, then that changes things.
You know, Devin, I would think, what are they, if they turn Lyft down, what are they doing? Suppose that they're just taking Uber. And it seems like the 50% turn down rate and the fact that this is a duopoly is not a coincidence. And if we assume Lyft and Uber are indistinguishable, then switching doesn't really cost them anything.
Yeah.
So, right, I mean, if they have to walk home with 3 bags of groceries, then that's a big cost. But, you know, opening the other app isn't very costly.
Yeah, it's a great point. So I think this whole welfare implications is complicated even more if you think about the competitive landscape of this industry. I think that's right. I mean, we have some evidence that not everyone checks both prices and then does the cheapest price. Because if they did that, we wouldn't see these discontinuities at dollar values. we would see a discontinuity kind of just spread out depending on wherever the Uber price happened to have been. And so,
well, yeah, that actually raises, I mean, if I intuit from my own behavior, which, as you know, has been my lifetime empirical technique, I'm more sensitive to the weight than the price. So I'll open the other app if the wait is unexpectedly long.
Interesting.
And I suppose there could be another interesting study for you is whether there's some kind of left digit bias on the wait, but it's rarely more than 10 minutes. So anyway.
Yeah, that's my guess is if they started reporting wait times in seconds,
right,
like 4 minutes and 59 seconds, then you would start to see discontinuities and shutting down the app at those left digits for sure. Yeah, that's interesting. All right, we are out of time. I want to make sure we don't go over. So I'll put up a conclusion slide, but I've already gone through all of this. So I don't know. I think this is kind of really interesting. I think we're bringing a lot of data to bear on a question that's already been studied some, but I think this kind of helps us gain some additional insights. And it also just helps us think about how firms are trying to incorporate and thinking about strategic situations when consumers have behavioral biases. Thank you all so much. This was awesome.
Thanks so much, Devin. Really excellent. And thanks to all of our panelists. Really fun today. And for all the audience for coming, lots of great questions, all of which I will give to Devin as soon as this is over, even if he didn't get a chance to answer them live. So we'll be back again next week. Thanks a lot for coming.
Thanks, everyone.